We're still missing some people, but I think we can get started anyway. So today's lecture is going to be shorter than usual. We'll just go for a little while, and when it's over, it's over. So we were talking about section 1.5, infinite limits. And we had been talking about infinite limits, basically just the definition. I want to get into how to compute these infinite limits. So
That's the kind of.
Sorry? Was there a question? Let's say x equals g over x divided by h over x is a function. And the limit as x goes to a of g of x does not equal 0. Let me make the yeah, actually I want to keep here. I want to keep this and the limit as x goes to a of h of x does equal 0. And let's make g and h both polynomials. Otherwise, there's a little bit more work we have to do. Then the limit as x goes to a of f of x, which is just g of x over h of x, equals either plus or minus infinity. And, oh, sorry, let x goes to a from the left of f of x equals either plus infinity or minus infinity. And the limit as x goes to a from the right of f of x equals either plus infinity or minus infinity. It's just up to us to figure out which. So if the top isn't going to 0 but the bottom is, then each of the one-sided limits is either plus infinity or minus infinity. So let's go ahead and take a look at an example. Let's take a look at the limit as x goes to 2 of, let's say, x minus 5 over x minus 2. Oh, sorry, limit as x goes to 2 from the left. So we're going to put a little minus sign right after the 2. Sure, that looks like it's in front of the x. It's not. It's just after the 2. So this is not connected to that. Limit as x goes to 2 from the left. Well, if we plug 2 in, we see that the top is not 0, but the bottom is. The top is not 0, but the bottom is 0. So right away, we know that this one-sided limit is either plus infinity or minus infinity. The one-sided limit is either plus infinity or minus infinity. All we have to do is figure out which. Let's say x is a number a little bit smaller than 2. That's what this says, approaching 2 from the left, a number a little bit smaller than 2. If you take a number a little bit smaller than 2 and subtract 5, you get a positive number or a negative number. You take a number.
Negative.
Yeah, you get a negative number. If you take like 1.9 or 1.99 and you subtract 5, you definitely get a negative number. So it's negative on top. And if you take a number a little bit smaller than 2 and subtract 2, you get a positive number or a negative number.
Negative.
Again, negative. So negative divided by negative, we know that's positive. So since the top wasn't going to 0, but the bottom is, we knew this one-side limit was either plus infinity or minus infinity. Now we know it's plus infinity because minus divided by minus is plus. Likewise, let's come in from the other side. The limit as x goes to 2 from the right of x minus 5 all over x minus 2. This time, x is a number a tiny bit bigger than 2. So if I, like 2.1 or 2.01, so if I take a number a tiny bit bigger than 2 and I subtract 5, I get a negative number again. And if I take a number a tiny bit bigger than 2 and subtract 2, this time I get a positive number. And so negative divided by positive is negative. There's only 2 possibilities because the top wasn't going to 0 and the bottom was. So negative divided by positive is negative. This is negative infinity. So if I had asked for the limit as x goes to 2 of x minus 5 over x minus 2, you would have said, okay, top's not going to 0, bottom is. I know that the one-sided limits are either plus infinity or minus infinity. If this was the original question, you would have to take the initiative and do those 2 questions yourself to see if they were the same. If they were both plus infinity, the answer would be plus infinity. If they were both minus infinity, the answer would be minus infinity. But one's plus infinity, the other one's minus infinity. They don't match. So this limit does not exist. But you cannot answer this question unless you've answered those 2 questions. So if this is the question on the page, you got to go back and do that. Let's just do one more. Let's say we have the limit as x goes to 1 of x minus 2 over x minus 1 squared. So it's another one of those cases where the top is going to something that's not 0. So this isn't like a 0 divided by 0 thing where we factor and cancel. The top's going to something that's not 0, but the bottom's going to something that is 0. If we plug 1 into the bottom, we get 1 minus 1, that's 0. Square that, you get 0. So if we go ahead and look at this, we know the one-side limits are either going to be plus infinity or minus infinity, and we just have to figure out which. So we have to take the initiative and do the 2 one-sided limits. We have to go limit, as x goes to 1 from the left of x minus 2 over x minus 1 squared. And we also have to do the limit as x goes to 1 from the right of x minus 2 over x minus 1 squared. It's our job, if we see this on the page, to do these 2 problems, see if these 2 match or not. Over there, they didn't. So if x is a number a little bit smaller than 1, x minus 2, if I take a number a little smaller than 1 and subtract 2, I get a negative number. If I take a number a little bit smaller than 1 and subtract and square it, I don't even have to worry about whether this is positive or negative because I'm squaring it. That's coming out positive. Minus divided by plus is minus. We knew before we started, since the top was not going to 0, but the bottom was, that it was going to be plus or infinity or minus infinity. This time it's minus infinity. If x is a number a little bit bigger than 1, like 1.1 or 1.01, x minus 2, again, is negative. And x minus 1, who cares what that is, really, because we're squaring it, that's positive. Minus divided by plus is minus infinity. That matches that. So it's perfectly okay to say that this is minus infinity. Basically, what we just discovered is we have a vertical asymptote at x equals 1, and it goes down in both directions next to x equal 1. It goes down from the left and it goes down from the right. It's going all the way down to minus infinity. Now, I want to remind you of something that you learned, hopefully, in a pre-calculus class at some point. And we talked about this briefly when we did our review of pre-calculus. So rational functions, polynomials divided by polynomials, can have only two kinds of discontinuities. Removable, just a hole in the curve. And vertical asymptotes, so an infinite one. Vertical asymptotes. How do we tell which is which? This is something that you knew, hopefully you still know. Let's take a look at an example. Find and classify all discontinuities. Let's say f of x equals x squared minus 3x plus 2 over x squared minus 4. Well, we can factor what's in the numerator and what's in the denominator. The numerator factors as x minus 2 times x minus 1. And the denominator factors at x minus 2 times x plus 2. So right away, we can see where the discontinuities are. We know that a rational function is continuous everywhere that it's defined. This function is defined everywhere except where the denominator equals 0. So our discontinuities are at x equals from here 2 and x equals from here minus 2. Now, we know I can't go ahead and just draw a line through the x minus 2 on the top and the x minus 2 on the bottom and cancel them. As much as I would love to do that, I can safely inside the limit. But if you can cancel the top and the bottom inside the limit, which we can for this x minus 2, so that goes with the x equals 2, then what we have is a hole in the curve. So this first one's a hole in the curve. In other words, a removable discontinuity. We can't actually go ahead and do that cancellation unless we have a limit. But if we had the limit, we could do the cancellation, and that x minus 2 on the bottom would disappear. This is just a hole in the curve. There is absolutely nothing we can do with this x plus 2, even if we had a limit in front. There's nothing to cancel it with. That becomes a vertical asymptote. That's how you tell. If you can cancel the thing on the bottom with something on the top, it's just a removable discontinuity. You can remove it. If you can't, it's a vertical asymptote. So an infinite discontinuity. And if you want to call it an infinite discontinuity a vertical asymptote, that's completely fine with me. Well, that just about does it for infinite limits. How do you feel so far? Is this good? Okay, let's just touch on section 2.1. Be working on this for a little bit because what we're doing here is really getting into the meat of the course, and there's a little bit of work to do to build up. So derivative and the tangent line problems. So consider the curve. Y equals x squared. I am just using x squared as an example. There's nothing magic about x squared. I'm just saying, here we are. Somebody's handed us y equals x squared. That's why I'm using it. Nothing special about this. We know what the graph looks like. Let me try to draw it reasonably carefully. We know it's a parabola. Probably drawn it a dozen times. So it goes to the point 1, 1, 2, 4, minus 1, 1, minus 2, 4. I apologize in advance for my lousy drawing. And let's say I ask you to find the slope of the line that crosses the curve at x equals 1 and x equals 2. For instance, again, I'm just picking these numbers x equals 1 and x equals 2 out of thin air. Somebody has handed you this problem. Find the slope of the line which crosses the curve we have over there, at x equals 1 and x equals 2. You look at this and you go, that's not a hard problem. To find slope, I'm going to need a couple points. If it crosses the curve, so let me just sketch that line in, by the way. So I'm going to need a couple points. The x coordinate of this first point is 1. The x coordinate of the second point is 2 because I said at x equals 1 and x equals 2. For this particular curve, how do you get the y coordinates? What do you do with x to get y?
Set it equal to 0.
No. If you have an x coordinate on this curve, how do you get the y coordinate?
Put it in the equation.
Right, you just put the x in and square it, right? Because it says y equals x squared. So if the x coordinate is 1, the y coordinate is just going to be 1 squared. That's just 1. So we just got that 1 by taking 1 and square it. And for the second point, x is 2. So y is going to be x squared. 2 squared, that's 4. For this curve, you always get the y values. For this particular curve, you always get the y values by taking the x value and square it. So that 4 came as 2 squared. If I gave you a different curve, we would do a different thing to the x to get the y. So we got 2 points. Now finding a slope is easy. We know how to find slope. M equals like y2 minus y1 over x2 minus x1. So this is like our x1 and y1. This is like our x2, and this is our y2. So y2 minus y1, we sometimes call that the rise. 4 minus 1, all over x2 minus x1. 2 minus 1, 4 minus 1 is 3. 2 minus 1 is 1. That's just the number 3. Nothing to it. You're given the curve and you're given the x values. You have half the point already. You have the x coordinates. To get the y coordinates, there's nothing to it. Just plug the x coordinate into whatever curve you're given. And then you know to find the slope of a line, y2 minus y1 over x2 minus x1. So this line, which touches the curve at 2 given points, is called a secant line. So a secant line touches a curve at 2 points that are specified. Finding the slope of the secant line was easy. I could find the equation of the line because I know a point that goes through it. Once I have a point and a slope, that's easy. But let me ask you a different question. Find the slope of the line that just grazes the curve. X equals 1. So the line, which if I could like put a ruler up against the curve, It just grazes the curve at x equals 1. Let me try to draw that. So that line there, the one that just grazes the curve at x equals 1. So a line which just grazes a curve at a given point is called a tangent line. Tangent is the Latin to touch. And hence, we have tangent line in the title of the section. Why is this a much harder problem? Why was the first problem where we found that secant line so easy? This one's hard.
Well, we only have one X and one Y.
Yeah, exactly. We only have 1 point. Over here we had 2. We've always needed 2 points to find the slope of a line. Now we only have 1. What are we supposed to do with that? I mean, you can see just by looking at the picture that this line is not as steep as this line. So we know the slope of that line is going to be less than 3. But that less than 3 includes a lot of numbers. So yeah, we only have 1 point. Before we had 2, it was easy. Now we have 1. It's not immediately obvious that there's any way of doing this at all. Anyway, I'm going to end lecture early today. If you have any questions, I'd be happy to answer them. But other than that, I will see, well, I was going to see you on Wednesday, but I will see many of you or most of you at noon because I'm speaking in first year seminar, the Common Experience today. So I will see you then.
I have a question that's
Yes.
unrelated though. When you give the assignment and you say refer to the textbook for the problem, which edition are you using? Because
The edition that it says in the syllabus, so the 8th edition.
okay, I have the 9th edition and then one question everything was a different.
Yes, that's so. I actually don't like this about publishers. They, just shuffle around the problems generally. There's no substantial difference, and then they sell the new versions of the text at exorbitant rates. That's why I deliberately chose an old version so that you could get the book, basically cheap. It's just as good as the new one, in my opinion. Any other questions?
I do have a quick one about homework as well. So, like the homework on your webpage. Sorry, that's my cat.
It's all good.
That's like, is that due just before class, like the next class?
No, so so you can double check the syllabus at all. We also have that there. Homework assigned, say on a Friday, is not late until the day the weekday after the next class period. So homework assigned on a Friday is not due until Tuesday morning at 9 a.m. Homework assigned on Monday is not due till Thursday morning at 9 a.m. and so on.
All right. Okay, thank you.
Sure. And I've been asked this a couple of times. The practice problems you do not have to submit. I choose odd numbers for the practice problems, and the solutions for the odd number problems are all in the back of the book, so you can double check your own understanding. Any other questions? All right, I will see you all. Well, I'll see most of you in a couple hours.